Hello, and welcome to this algebra lesson on solving a system of linear equations by substitution. When we have a system of linear equations, it means we have linear equations and we have more than one of them that we want to have true at the same time. Now, in the problem that's marked problem 3 here, you can see we've got y equals 5 and y equals x plus 13. This is the simplest type of substitution. Basically, in substitution, you're looking to take your two equations and then use one in the other to make one equation with just one variable. If I were just asked to solve the y equals x plus 13, there are infinite solutions to that. There are many points that will make that true. But I also have this other constraint here of y equals 5. So I'm told two things that must be true of y. It must be 5 and y must also equal x plus 13. So for the equation, for the system I'm interested in, I need to find the x that will make both of these things true. I'm told already the y. When you have the y isolated like this, it says you can replace y in the other equation with 5. So the other equation is written here, the second one. So that means I can replace this y with 5 because I want both of these equations to be true at the same time. So it will have to be true that y is 5 because that's what the first equation tells me. You just take the y from the first equation and use what it's equal to replace the y in the second equation. Now I just have one variable and I can solve for x. I see I have an x plus 13 on the side. To get x by itself, I subtract 13 from both sides. When I subtract 13 from 5, I get 13 minus 5 is 8. The 13 was negative, so I get a negative 8 equals x. So I'm saying the solution to this is negative 8 equals x and y equals 5. Let's see if that makes both of these equations true. So now to check it, I'll just pick up a different color here to check it. To check it, my first equation says y equals 5. Oh, yeah, that's true. My second equation, I have to replace the y with a 5 and the x with a negative 8. And now I have to see, is it true? Does 5 equal negative 8 plus 13? Yes. So my solution to this system is the point x equals negative 8, y equals 5. It can be written as a point, can be written out this way. Lots of times in electronic homework and online homework, they will want you to write this as a point. Now, that one, maybe you're okay with because it's just like I gave you y equals x plus 13 and said, now replace y with 5 and solve for x. This one, neither one of my equations, over here on the one on the right, neither equation is a number. That's okay, the same process works. I'm told in the first equation that y is the same as negative 7x minus 9. So in the second equation, I'm told y equals negative 3x minus 1. So I can replace this y with what I was told y was. And now I will just have x's in my equation. Now, students sometimes find these difficult because you have a variable on both sides. Let's talk about the basic principles of solving this. You want to put all of the x's on one side, anything without an x on the other. It doesn't really matter which side you start with. I'm going to move this 3x over here by adding 3x to both sides. And what that does is that gives me, these are 0 x's now. I just have a negative 1 there. I have a negative 4x minus 9 equals negative 1. Now I finish solving. It's an equal sign. I add 9 to both sides. And hopefully you're pretty good at this by now. Negative 4x equals 8. Divide both sides by negative 4, divided by negative 4, and I get x equals negative 2. So now what is y? Well, you can take x equals negative 2 and put it into either of these equations to find y. So I'm going to erase some of, well, I guess I can only erase all, so I'm not going to erase. X is negative 2. Let me pick a different color now. Well, let's see. So I'm going to use the x is negative 2. Y equals negative 7 times negative 2 minus 9. That'll give me positive 14 minus 9, which will give me 5. So I'm getting y equals 5 would be my solution. If I want to check the solution, it should make this bottom equation true also. So the question becomes, is 5 equal to negative 3? And I'm taking this from the bottom equation, times negative 2 minus 1. Negative 3 times negative 2 will be a positive 6. I get a 5. 5 equals 5. Yes. So the solution to this system in what's labeled problem number 4 here, although it's really only our second problem, would be x is negative 2 and y is 5. That is another example of solving a system of equations by substitution. Okay, hope that helps. Email me your questions.